Here, Arnav and Abhinav are two rising high school seniors from Loudon County. They noticed an issue with the way firefighting is done today and wanted to help out. The idea, they say, came to them after a personal tragedy.
So last year in October of my junior year of high school, unfortunately, an old house that I used to live in when I was younger and when I was like around 5 years old to 10 years old, unfortunately burned down in a house fire. So that event sort of directly led me to think more deeply about my community, my environment, more directly towards like fire-related issues, and understanding like what could I do based on this event that happened to me that I could take that and use that experience to help guide me to create something new.
Awesome. Well, let's get into what you built. Here's a nice model of it being worn. And then the tech itself. What we're looking at is kind of two sensors, right, that each detect a different thing, and they each go on the helmet, and they help the firefighters see without needing to really make an image. Can you explain how the thermal camera and the wave radar work together?
Yeah, absolutely. So in this iteration of the prototype, we just attached the wave radar, but in the case of the thermal camera, it essentially uses a thermal sensing module within the camera to be able to essentially take the surroundings and pixelize it in a way that is visible for the Jess and Nano. This is different than regular cameras, such as standard cameras that you see in an iPhone, because this one is able to essentially determine the heat signatures of the objects, people, surroundings, whatever is in front of them, and establish that within the camera. This specific camera is called the Infiniray P2 Pro, and this was especially useful for us because of its size. It was sort of a smaller, more compact size that would easily fit within the context of a prototype. The other component they mentioned, we're still working on sourcing the part for the wave radar. That's definitely something we want to implement further to sort of further create a relationship, as we kind of wrote about in the white paper, to establish more context on the environment.
All right. So I want to pull up this video you sent in. Is this kind of what is created by a thermal sensor?
Yeah. Yes. So if you look at the plain sort of red background, that is just the plain thermal camera background. On top of that, we are using sort of the AI algorithms that we created, and we can explain that to basically have multiple different modes on top of that. So one of the modes is the edge detection mode. So essentially, we're using a algorithm to basically dissect the image into multiple edges. So it kind of goes pixel-wise within the image and is able to determine features in real time using sort of the AI algorithm. And we're able to display that in real time in the screen. So in the actual helmet itself, there's a screen over here, and then the person wearing the helmet is able to see the edges of the surroundings. And then this edge view is also visible on the software side. So for the helmet, it's going to be deployed by a firefighter in a building, right?
Yeah.
During that process, an incident commander who is kind of overseeing the operation is also able to see the screen in real time. So they're both able to see the very exact same view. So on that screen, they're also able to see the same view of the edge detection.
So you need the data that's being sent back by the chip in the helmet to be small enough to go back quickly and be readable. But another thing about the display, I believe Loudon Now reported Chief Sullivan, Loudon County Police Department, Fire Department, who you've been working with, saying, First of all, having the thermal imager on the helmet would free up a hand. They're usually holding their thermal imager. But another thing is, firefighters don't want to see another full picture in their heads-up display, right? So you're just doing kind of outlines of things?
This is a prototype at the end of the day. Our next iteration or stage is actually making a hinge-type mechanism to flip that module up or down whenever they need, and that's our next step.
Awesome.
But kind of go back to the question as well. It does sort of create the lines, as you mentioned, but I think another useful part of it is the object detection mode. So This is distinct in that we're using something called YOLO V8. This is known as like you only look once. It's like a common object detection algorithm used in machine learning literature. And we're essentially able to implement that in real time within the NVIDIA chip on the module. So then it's able to kind of see in the environment and see objects such as humans, couches, doors, everyday things. And it's able to identify that and label that in real time to, let's say, the firefighter who can then see it within the screen, as you can see here.
Yeah, and then one thing I found stunning is the detection precision that you already have here. In the
Absolutely.
high 70s, low 80s so far for even things as a person and a door and a stair and an obstacle. And of course, a firefighter is going to need to be able to see all of that through thick smoke, which is why you've created this project. So back to what Abhinav said, this is a prototype. If you plan on continuing, what is your next step now that you've perhaps gotten some grants? A lot of people are going to be watching this and all that you've been doing. What's the next thing you're going to add to this helmet?
Definitely. So as you can see, the prototype mainly is heavy on the front side. We want to improve its balance of gravity. So moving some stuff around, making it more universal, maybe to work with multiple helmets would be a great option for us. And like I said, that hinge mechanism is also one of our next steps, as well as implementing a new programming software called SLAM, simultaneous localization and mapping,
right,
where as a firefighter is going inside a house, there's a software could use I guess you can say 3D modeling in real time, and it could send that out to the incident commander. Arnav can talk more about it.
Yeah, absolutely. So essentially the SLAM model that we're trying to implement will kind of create 3D point clouds in real time. So as the firefighter is moving within that environment, it'll create clouds, and you kind of see in the bottom bottom view of that image. So it kind of creates those point clouds around the firefighter, and that is able to sort of create the 3D environment. We're working on implementing it. It's a version of it called Thermal SLAM, which is interesting because it's primarily just for those thermal cameras. Another interesting feature so recently we talked with the firefighters, and they mentioned that one of the biggest problems is that firefighters often they often slip into holes, right? So as they're walking in the environment, they often see holes, and they're often unable to see holes below them, and they're often falling into those holes. So there hasn't been a way, according to them, to be able to accurately detect those holes before they appear in the firefighter's vicinity. So we want to add a feature that allows the camera to be able to detect any holes in the nearby environment as they're walking in the scene, to be able to better inform them of the danger.
What we also want to do is add a sound sensor with the camera to work in compatible to make this possible, of course.
All right, way to go, guys. Up, up, and away. Arnav, Abhinav, thank you so much for joining me on the Live Zone today.
Thank you for the opportunity.
All right.